My dear friends, welcome back to BSpice. In this session, we'll continue with OT cybersecurity, wherein we'll focus on OT system design considerations. So, design consideration in the sense in terms of safety, in terms of control timing requirements, in terms of geographical distribution, in terms of hierarchy, in terms of control complexity, in terms of availability, and in terms of impact of failures. So, these are the things from a design point of view we are going to discuss. So before going into the design aspects, so I wanted to give you an outline about the what do you call the OT system, components, architecture, all these. Okay, let us discuss this first before going into that. Okay, let's get started. So OT system, operation, architecture and components. As you can see here friends, a typical OT system contains numerous control loops. You can see here and a human machine interface and of course remote diagnostics and maintenance tools. So the system is built using an array of network protocols on layered architecture. You would have seen that in our Purdue model, right? Like right from level 0 to level 5, right? Yeah. So it's basically layers of architecture. So some critical process may also include safety system, right? ESD system. That's basic things, right? In terms of complexity, we go for a safety system. A control loop utilizes sensors, of course, actuators, controllers, right, to manipulate the control process. Okay, manipulate some controlled process. It's very basic. Of course, many of you are aware, but again, I want to, touch upon a bit before going into the design. Okay, so let's continue with the operation architecture components. Sensor again. A sensor is a device that produces a measurement of some physical property and then sends this information to the as a controlled variable, right? As a control variable to the controller, right? Okay. So the controller interprets the measurements, right, and generates corresponding manipulated variables based on the algorithm and target set point, which transmits to the actuator. Right. So actuators such as, control valves, breakers, switches, motors are used to directly manipulate the control process based on the commands from the controller. Very basic. Okay, in a typical monitoring system, there are generally no direct connection between the sensors and the actuators, isn't it? Right. So sensor values are transmitted to a monitoring station to be analyzed by a human, right? Okay, right. So, however, this type of system still be considered OT system. Okay, although with a human in the loop, right? So, because the objective of monitoring system is likely to identify and ultimately mitigate an event or condition. Okay, so that is the point actually. Okay, so I just want to put for some basic things from here. See, what I meant here is, even though some loops are open loops, so that is also part of the OT system. Okay, right. So operators and engineers use human machine interface, right, to monitor and configure the set point algorithm, set points control algorithm, and adjust and establish parameters in the controllers. So HMI also display process status information and historical information. So this all we know. So diagnostics and maintenance utilities are used to prevent, identify and recover from abnormal operation or failures. Nowadays a lot of diagnostics are available, right? So sometimes, control loops are nested or cascaded, whereby the set point of one loop is based on the process variable determined by the another loop. Typical example is the cascade loop, right? So supervisory level loops and lower level loops operate continuously over a duration of a process with cycle timing ranging in order of milliseconds to minutes. So this all about, just want to give you some basics from that's it. Now we go into the design consideration. See, the design of a OT system depends on many factors, including whether a SCADA, DCS or PLC based topology. Okay. As I highlighted earlier, safety, control timing, geographical distribution, hierarchy, control complexity, availability, and impact of failures. So here we see the key factors that drive design decision regarding control, communication, reliability, and redundancy properties of the OT system. Because these factors heavily influence the design of OT system, isn't it? I hope you agree. So they also help to determine the system security needs. Okay, let's see one by one. So safety. System must be able to detect unsafe condition and trigger action to reduce unsafe condition to a safe one, isn't it? So in a more safety critical operation, human oversight and control of potentially dangerous process are essential. So safety is the utmost importance. Then control timing requirements. System process have a wide range of time related requirements, including, sometimes very high speed, consistently meet these requirements. So automated controllers may be necessary. Some system may require computation to be performed as close to sensors and actuators as possible to reduce the communication latency, delay of signals, and perform necessary control actions on time. So basically, what I meant here is control timing is important. Okay, then geographical distribution. Some systems have varying degree of distribution ranging from small system like a local PLC to a large distributed system like oil pipelines or electric power grids. So greater distribution typically implies a need for a wide area network. Probably, like a leased land, circuit switching, packet switching, all these, type of technologies and mobile communication. And hierarchy. So when we talk about the hierarchy, yes, supervisory control is used to provide a central location that can aggregate data from multiple locations to support the control decision based on the current state of the system. A hierarchical or centralized control is often used to provide human operators with a comprehensive view of the entire system. So hierarchy is also important. Then the most important, control complexity. Simple controllers and preset algorithm can often perform control function. However, more complex system like, for example, air traffic control require human operators to ensure that all control actions are appropriate for meeting the larger objective of the system. So control complexity also add to the, design factors, design consideration. Then availability. This is also very important. System with strong availability and uptime requirements require more redundancy or alternate implementation across all communication and controls. That's about the availability. Then impact of failures. The failure of a control function could cause substantially different impacts across domains, right? So system with greater impacts often require the ability to continue operations through redundant controls or to operate in a degraded state. So these are the things I just want to put forth as part of the design consideration for OT system. So thanks again for watching and keep watching friends and keep supporting. Coming up next, the big one, IT versus OT. I hope you are all waiting for this. Yes, IT versus OT. I'll highlight the differences basically. Differences in the sense differences in terms of performance requirements and like availability, risk management, physical effects, operation, communication, all these I'm going to highlight this the differences friends in the next video. Stay tuned. Thank you for watching. Take care. Bye bye.